Hello everyone, this is Apsana and today I'm going to talk about the heat capacity of a metal and we are going to find the heat capacity of a metal by using a lab experiment using a calorimeter. Before I go and talk about the experiment, let me talk what is heat capacity. It is simply the ratio of the amount of heat energy transferred to the object and the resulting change or increase in the temperature of an object. It is denoted by C and simply written by this equation. The SI unit for heat capacity is joules per kilograms per Kelvin. I told you that we are using a calorimeter to use this. Now let's define what is a calorimeter. Before I go into that, what is a calorie? Calorie is the heat energy required to raise the temperature of 1 gram of water by 1 degree Celsius in 1 atom pressure. And the calorimeter is simply the device which is used to measure the heat. And in our case, it is going to be a coffee cup calorimeter, which is simply 2 coffee cups, 2 styrofoam cups to be precise. Here we go. Let me make a calorimeter here. It's very simple. We just need to have 2 coffee cups nested onto each other. Put another coffee cup, styrofoam cup on top of another. And we require a lead for that. It can be anything, cardboard or paraffin. Let's use a paraffin in our case and cover our calorimeter of styrofoam cups. We also need a rubber to hold our paraffin here. And we also want to make here 2 holes because we have to insert a thermometer and a thermoprobe. This is a thermometer and this is a thermoprobe which is connected by wire. And it is connected to the computer, which I'll discuss later. Now, what are the apparatus required for our experiment? Let's discuss about that. We would require a graduated cylinder, let's say of 250 milliliters. We also require a beaker, a 500 milliliters beaker. We require a hot plate. Also, like I already told you, we require 2 styrofoam cups, a thermometer, a thermoprobe, which is connected to a software which can be GoPro or GoLink interface software. And most importantly, we would require the metal of which heat capacity that we're going to measure. It can be any metal, whichever we want to find the heat capacity. Let's say in our case it is copper. Now, having all the apparatus, let's go and see how we perform this lab procedure. The first part of our procedure is already done. That is to make the calorimeter, which is really simple. We just need to nest the styrofoam cups together. We need 2 holes and another hole here to connect our wire, which is connected to the computer software. And we require the thermometer here. Now what we do is we measure 250 milliliters of water in a graduated cylinder. And we put it in our styrofoam cup, which is our calorimeter. Now there's a temperature, there is a thermometer which measures the temperature of the water. Let's say its temperature initially is 25 degrees Celsius. I'm just supposing this. And side by side we can have our experiment going on. We can have a hot plate on which we can have a beaker full of water. Let's say 500 milliliters of water inside it, and we'd connect this hot plate and we would let this water to boil. While this is boiling, let's go ahead and measure the weight of our metal, which is copper. using a beam balance. Let's say supposedly the weight of our metal is 3 grams. Now we need to put this metal into the beaker when this water is boiling. So let's put very carefully, we use a tongue here and put the metal inside the boiling water. After the temperature of water and the temperature of the metal reaches the equilibrium, we need to take this metal out from this hot plate very carefully using tongs obviously, and we need to transfer this metal into the calorimeter, which has water initially, whose temperature has already been measured. Now while we do this, we have to be very careful because we got a hot beaker which has boiling water. So when we take out the metal from here, it is really hot. So we either have to use gloves or we need to use gloves and tongs so that it doesn't burn. After we do this, what we need to do is measure the final temperature of the water, because there will be change in the temperature of water since the hot metal is placed inside our calorimeter. Now basic procedure for this experiment is already over. The system of this experiment is the metal and the water, and the surrounding of our experiment is the cup and the environment. Now here, energy is transferred from the metal to the water in the form of heat. So let's say that is Qm, and the heat in the water, water gets warmer because heat flows from the metal to the water. So let's say that is Qw. Now since we have assumed that there is no loss of energy into the surroundings, and also due to the laws of conservation of energy, Qm plus Qw will be equals to 0. Let's say Qm plus Qw is 0. We already know what is Qm. Qm is simply the specific heat, that is M. Heat capacity of the metal times the mass of the metal, which we have already measured, that is 3 grams, times the temperature. Also we know what is Qw, heat capacity of water, which is known to us, mass of the water, which we have already measured, and the temperature, which also we have already measured. All we need to do to find out the heat capacity of this metal is to simplify these two equations. We just can write here Cm, that is the heat capacity of our metal, will be equal to, this is times this equation divided by these two factors here. So that will be the heat capacity of water times mass of water times the temperature difference divided by mass of our metal times temperature of the metal. So in this way, by just substituting and simplifying, we can find the heat capacity of our metal, which is copper in case of our lab experiment. Let me tell you why this experiment is really useful and convenient. First, because it is very cheap to perform, because all we need is a styrofoam cup here, which is really inexpensive, and a metal which can be used again later after cooling. So this metal literally can be used for further experiments because it is reusable. Also, it's a very safe experiment to perform. The only safety that we need to keep in our mind is transferring the hot metal from our hot beaker to the calorimeter. So there is not much hazard while performing this experiment. So in this way, a coffee cup calorimeter can be used to find out the heat capacity of a copper metal or any metal that we like. Thank you.